Zombie apocalypse.
I'm Dr. Emily Grossman. Welcome to Cinema Science, the show where we check out some favourite films to see if the science they contain is up to scratch. This week, we're looking at explosions in space. If you're a fan of science fiction or space movies, you'll have probably caught yourself looking forward to that epic moment in movies such as Star Wars or Ender's Game, where the enemy spacecraft is finally shot down, exploding into a massive fireball with an enormous boom and sending debris flying out in all directions. On Earth, explosions normally happen when a material is subjected to a huge amount of heat or pressure. The heat and pressure build up until there's a sudden outburst. If the gas is flammable, it can act as a fuel, and the heat can be enough to cause it to burst into flames, generating a massive fireball, with the accompanying pressure wave giving rise to an enormous boom. Now, if you remember your fire triangle from school, you'll be familiar with the fact that fire needs three ingredients: fuel, heat, and oxygen. And it's this need.
This is a glass of water, and this is outer space. Now imagine that the glass of water is in space. What do you think would happen to the water? Would it freeze, or boil, or something else? To think about this question, we need to understand that space is a vacuum. That means it's empty. There isn't any water, or land, or even air. It's empty, except for our imaginary glass of water. We can simulate the emptiness of space in an experiment by putting some real water inside this vacuum chamber. All the air is being pumped out, creating a vacuum similar to outer space. As the air is pumped out of the chamber, the pressure decreases and the water begins to boil, even though it's not hot. So that's what would happen to water in outer space, for you to think about. Wait, come back. The water isn't boiling anymore. It appears to be freezing. When the water boiled, it changed from a liquid into a gas. That change took energy in the form of heat away from the liquid water, causing its temperature to drop until it froze. We'll let the air back into the vacuum chamber to make sure. It's ice, all right. Now that is something interesting to think about.
Is the problem. In space, the gravitational attraction of large bodies such as planets and stars pulls the gas molecules in the air towards the surface of these bodies, leaving virtually none behind in the vast spaces in between. So space is a vacuum, a nearly total absence of any gas molecules, including that all-important third ingredient, oxygen. In the absence of oxygen, fuels simply cannot burn, so a fireball in space should be impossible. However, this is not quite the case. If the exploding aircraft happen to contain liquid oxygen, as they often do, this could be enough to allow the hot gas to catch fire, producing a burst of light. After a brief moment, the oxygen would be used up and the fire would go out. Not exactly the dramatic raging infernos that we see in the movies. Another problem is the big boom. When sound energy passes through a solid, liquid or gas, it relies on the vibrations of the particles making up the medium. The lack of air particles in space means that sound waves simply can't travel. So any explosion would be completely silent. So the famous tagline for Alien is true. In space, no one can hear you scream. Even the movies that get space explosions nearly right tend to miss one important detail. In the movies, a spacecraft hurtling through the cosmos usually stops dead in its tracks as it explodes. However, in reality, an exploding spacecraft should continue moving forwards, as there's no air resistance to slow it down. So next time we see a spaceship explode in Star Trek, we should expect to see the remains travelling on forever, with the debris appearing in one of the TV episodes 10 years later. If you remember your fire triangle from school, you'll be familiar with the fact that fire needs 3 ingredients: fuel, heat, and oxygen.